Hi there. This is a brief introduction to our most recent paper. This paper is about real-time epidemiological analysis of COVID pandemic in Switzerland. This work was made possible by the Epigraph Hub platform. The Epigraph Hub platform is a software developed by our research network, the Graph Network. Let's get right into it. If we take a careful look at the incidence curves for every canton in Switzerland, we'll notice right away that they not all peak at the same time. There's some lead time between canton and another canton. This has to do with the natural spread of the disease. In this paper, we will explore this information to feed a forecasting model for hospitalization and cases. Let's see how it works. Before we get there, it's worth mentioning that the data for this analysis was made possible by the daily data made available by the Federal Office of Public Health in Switzerland. Without this data and the ability of the Epigraph Hub platform to automatically integrate this into its database, this work wouldn't have been possible in its scope. In order to make the best possible use of the available information, we perform a spatial temporal analysis on the incidence data by calculating the pairwise correlation between every pair of canton in the country. In that analysis, we were able to estimate the time lag tau that maximizes the correlation between cases. We will later use this information to properly choose which cantons can be the best predictors possible for incidence on other cantons. But before we dive into the forecast model, let's take a closer look at the hospitalization rate in the whole country. If we make a simple scatter plot of hospitalization against cases, it's immediately clear that there were several different waves, which is not necessarily new. Everybody knows that. But we'd also see that in 2020, we had the highest hospitalization rate per case. That's also obvious now in retrospect, of course, because there was the beginning of the pandemic in Switzerland. Nobody was prepared, nobody was immunized, and the hospitals themselves were not ready to deal with the enormous influx of patients. Towards the end of the pandemic, in Q1 2021, for example, here, we have the lowest hospitalization rates. And that is a marked proof of the efficacy of immunization and protective measures that took place later on in the pandemic. So even a simple exploratory analysis of daily data like this one can be quite informative. Okay, let's move on to the forecast. After calculating the correlation between each pair of cantons, we can then cluster them in the more correlated groups of cantons. Those are colored here in this graph. Those clusters of cantons join together localities, cantons, that are better predictors among themselves because they are more in tune. So we will use this in the forecasting model, which looks like this. So the forecasting model that we use looks like this. In order to forecast hospitalization for every canton K on time T, we use information about cases for every canton K at times T minus tau, given by the optimal lag between the canton we're forecasting for and the canton that we are using here. The hospitalization rates, the same way, the number of tests, and the number of ICU beds. So the model has many more variables than those that are written here because of, for every C, there are all the cantons in the cluster, the same for hospitalization, the same for tests, the same for ICU. So this regression model is estimated using a probabilistic gradient boosting machine that will yield the following results. Here we can see the forecasts for Geneva and Bern in these first two panels. In this figure, we moved our forecasting post a little back in time so you could compare the forecast of of the model made for 15 days in the future against what actually happened. Not bad. But the model always predicts towards the future. Here we just moved it back so that you could appreciate how close to the actual dynamics of the system the model was able to forecast. As a last example, we have Zurich here, not so bad either. We actually did this for all cantons in Switzerland. This is available on our live updating dashboard, which you can find the link for in the description of this video. So that's it for now. There's much more fine analysis in this paper, but that will be too long to explain everything in this short video. I thank you for your attention and interest in our paper, and I hope you take some time to read it, comment, and perhaps use some of the information in there for your own research. Thank you.